All right, this is 8.4, page 424 in your textbooks. We're solving problems using trigonometry. So when we say trigonometry, we're referring to everything basically we started learning since chapter 7. So SOHCAHTOA, sine law, cosine law, those are our three main tools, I guess if you will. So here, the first question involves a bridge, so something common that you would see for civil engineer. We're just calculating the total length of all of the metal trusses that are required to build the bridge. Okay, so we're just looking at this bridge in kind of 2D right now, so we're not looking at the other side of the bridge, but what is involved in building this section of the bridge. Okay, so the information we're given in the very first triangle, we see that it's a right angle triangle. So right away that you guys should think to yourselves, what do I use to solve right angle triangles? SOHCAHTOA. Okay, so those are your trigonometric ratios. And after drawing the unit circles, you all should have a very good understanding of what those ratios actually mean and what they are. Okay, so here we want to solve for our first side length A, which again is opposite angle A, so we're looking at this side length here. Okay, if we need the total material, we actually need the side length for all the triangles. All right, so we're solving for our side length A. We do that by finding the sine value of angle A. So sine A is opposite. So we're looking at this angle. Opposite is side length A over the hypotenuse of C. Okay, we rearrange and solve for A. We get A is 3.7. Any questions there?
Why is it A over C?
Because it's opposite over hypotenuse. C,
yeah.
Little c is opposite big C. Okay? That's one of the things that I've stressed the last few sections now is the nomenclature of triangles. When you have your angles as the capitals, the side lengths are the small letters opposite those angles, the same letter. Okay? Next, we're trying to solve for side length B, which is over here. Okay, so we're going to use cos this time, so cos B. Cos A this time is adjacent, which is right here, over the hypotenuse of C, 6.2, is cos 37. Again, using that same angle now, we solve for B. And finally, because this is a right angle triangle, to find the value of C, we can use Pythagorean theorem to get this value of 6.2. This is just a confirmation, right? It was already given 6.2 in the question. Okay, so that Pythagorean theorem, this is just a check here. This is just a check of your A and B values. All right, next we're moving on into this triangle. Because we know the value of A and we have these dashed lines here, we know every single one of these sides is the value of A. So this is 3.7, this is 3.7, this is 3.7. Okay? Now if we're looking at this triangle BCD, and we want to look at sorry, that's what I just went over. All of those side lengths are 3.7. So I just drew. In triangle now BDE, so BDE is going to be over here. Okay, we want to look at the angle now. This is another way of, another type of nomenclature for angles. Okay? It says angle CBA. And the way this works, you're going to have to know this for this section in particular, but then also moving into grade 11. The way this works is you just follow those points to get the angle. So it's the trapped angle. So it goes CBA. So we're talking about this angle. The reason why we do that, okay, you might just say, well, Mr. Mills, that's just angle B. Okay? I don't know if you're referring to this angle B, or this angle B, or this angle B. All right? So that's why we have the three letters. Okay, that's very important. It's always the letter in the middle that the angle that we're referring to, but you have to follow those other two letters to find the exact value. Okay, so that's another kind of small nomenclature thing you need to know. All right? The little c is opposite the angle, the little letter is opposite the big letter, and then if we're using angle CBD, again, you go from C, go to B, and then go to A. So we're talking about this angle. So this angle here, we know that 180 makes up three angles in a triangle. If this is 90 and this is 37, I can find out this angle by subtracting 90 and 37, or 180 minus 90 minus 37. Same idea, it gives you 53. So this angle here is 53 degrees. Any questions there? So therefore, if that's 53 degrees, I know angle CBD is going to be 60 degrees in here. Okay, and that's, so BCD is an equilateral triangle. So this triangle here, BCD, we know that all of these angles are the same. Okay, the three interior angles are equal. Therefore, if they add up to 180, every single one of these angles has to be 60. Okay, everyone understand that? All equilateral triangles have three angles of 60. Okay, because they have to make up 180. So I know that this is 53. I know that this is 60. I know that this total angle is what? What's from here to here?
180?
Yeah, 180. So I do 180 minus 53 minus 60 is 67. So DBE, this angle here, is going to be 67. Okay? So that's my next one. Finally, I know that this is an isosceles triangle here. Why do I know that? Because it was given these two sides are the same. So I know if that's 67, I know the opposite angle over here is 67. Okay? And that is DBE, and BDE are both 67. If these two are 67, I can take 180 minus those two, and I get my third angle is 46. Okay? Now I can use the sine law to solve for my side length B. So my side length B is this side length here. This is B, so opposite angle B. I have three angles and I have one side length, so I'm definitely going to use sine law. I don't have to use cosine law. The only time I use cosine law is when? When do I have to use cosine law? David?
An angle and then the two sides of that. So like the angles in between the two sides that you know.
Yes, so if I have side, angle, side, so an angle between two known sides, or, yeah, well,
Only sides.
yeah, only all three sides, okay? In this case, I have an angle, I have a side, and I have the other angle. So an angle opposite a side and a third angle, I'm definitely going to use sine law. So if I use sine law here, I say B over sine B is equal to E over sine E. I put the side length on top because that's what I'm solving for. And then I calculate that B is 4.7. So this length here is 4.7. Okay? That's simply using sine law. Very quick and easy. Alright, so that gives my value of B. So then I just go and I add up the total lengths. Okay, all of these, as it mentions in the triangle, or sorry, as it mentions in the question, all three of these are repeated triangles. So we can just take those values then and multiply it by how many of them there are. There's three sides of 3.7, 2 of 4.7, and we get our total length. Any questions? All right, so we saw SOHCAHTOA, we saw sine law, and we saw a bunch of kind of compound and related angles. So that's all trigonometry stuff. The last question now, we will see a bit of the cosine law, which, you know, some might say arguably is the hardest. Actually, sorry, we don't see cosine law. We just saw it in the last section. But keep in mind, you could see cosine law if you were given a problem where you either had all three sides or a side angle side. All right, example number 2. It says, find the height of a cliff as shown to the nearest meter. So it's basically a river here. This is a river, and here's your cliff side. Here's your cliff. Okay, so I just wrote on the board, find the length of AB. That's what it's asking for. So you see this a lot actually in grade 11. And this is called a kind of 3D trigonometry problem. So if you look at the drawing on 426, you get a better idea of how this is supposed to look. But basically, here's the riverbed, and then this is going straight up. So you got to kind of imagine it coming straight off the board. Can you guys visualize that?
Yep.
So this triangle is going like straight up in the air, and this triangle is flat on the ground. Okay? One thing that you should notice though is that they actually share this side length. Okay, so that's key. So you need to transition from a triangle where you have a lot of information to a triangle where you don't have a lot of information to find the unknown. Okay, so that's the idea. So anytime you see these problems where it looks like a three-dimensional, you got to ask yourself, okay, what side length do they share? Because that's the one you're going to need, right? The question says, what is the length of AB? So if I try and find out AB right now, I only have the angle, this angle here. So even though it's a right angle triangle, using SOHCAHTOA, I still need two pieces of information. So I don't have that yet. So I need to find out this side length. If I can find out this side length, I can use tan, opposite and adjacent with the angle 33 to find out this angle. So if I can get this side length, I should be good. So based on the information given, I have two angles and a side. Remember, cosine law would be two sides with an angle in between, or three sides. So this is sine law. There's only one step I have to do before I can start sine law. Anybody tell me that? Because I don't have an angle opposite a side. So what do I have to do?
Cosine.
Yeah.
An angle of CBD.
Yeah, exactly. CBD. Good, very good. I need to find out this angle. So it's just going to be 180 minus 62 minus 50. I know that's 68. And that's important because to use the sine law, you need to have an angle opposite another angle because that's the way the ratios work for sine law. Okay, so once I have that ratio, I have all the information for this ratio here, CD and angle CBD. So I have 160 over sine 68 is equal to BC, which is this side length here. This is BC, which is the side we want to know for the second triangle, over sine 50. So over the opposite sine 50. Solve for BC, I get BC is 132. So I know this is now 132. If I have the opposite side and an angle, I can solve, 132 is this side. I'm sorry, so this is 132. I have the adjacent side and an angle. I can solve for the opposite side by using the tan ratio. So tan ACB, which is 33, is equal to AB, opposite, over 132. Solve for AB, which is 86. Any questions there? So not overly difficult. I don't think this is necessarily a challenging section, but definitely need to do the homework and just get your practice. It's all word problems. Okay? The hardest thing might arguably be just setting up the drawing correctly. All right, so finally, key concepts. This is just a repeat from the last section as well. When we have right angle triangles, we're going to use SOHCAHTOA. When we have sine law, that's for acute triangles. And so we have these scenarios: side, angle, angle, side, side, angle. Basically every other scenario except for cosine law, where we have side, 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 and side, angle, side. So again, always looking for cosine law. First, if we don't have this special situation, you're going to use sine law. Any questions? All right, that's it.